Hello all, welcome to the part B of lecture 10. In this video, we are going to do some hands-on using Julia on Chennai's temperature data. So we will open Julia notebook. We want to open the Julia 1.8.2. So first we'll give some headings that Chennai's temperature analysis using Julia. So let me run it. Now, first we will do using CSV, data frames, TS frames, dates. So these are the packages we will need. CSV will read the CSV file and then we will put it in a data frame. TS frame is another package which is built on the top of data frames. It helps us to handle time series data, and then dates are essentially help us to do some date operations. So let us run this. Next we will do read CSV file into data frame. Okay, so read CSV file into data frame. Okay, so what we will do, we'll say df data frame from CSV dot file, we'll do open quote unquote, and then this is the file that we want to read, and let us run that. So it has read 11,894 rows and 5 columns. So first column is time, but it read it as a string. So date is rated as a string, so we need to convert it into string. T average is the average temperature of Chennai. T mean is the on that particular day. So 25.2 is the average temperature of Chennai on 1st January 1990. So T mean is the minimum temperature of Chennai on 1st January 1990. T max is 28.4, which is 28.4 is the max temperature on 1st January 1990. And precipitation 0.5, some precipitation took place on that particular day. So next what we will do, we just want to work with the average temperature and the date. So we will keep these two columns, and so that it will become we don't have to worry about the other columns. Okay, so what we will do, we will just say df colon, and we will have time comma T average VG, and we don't want to print the entire column, so we will just say first print the first 5 columns. So now it has printed the first 5 columns. Now df has only 2 columns, time and the T average. Okay, now we will do some data cleaning and data pre-processing. Okay, so data cleaning and pre-processing. So okay, so the first thing we will do, we will take this string and we will just convert it into date column. Okay, so df dot time, from df I'm just extracting the time dot df dot time comma, the format that we have is ddmm y. And obviously I don't want to print the whole thing. If you don't give this semicolon, it will just print the whole thing. If you go up, you see I have not put that semicolon, so pretty much it printed a big chunk. So I don't want to print the big chunk. So I want to just say, okay, print the first 7 columns. Okay, it has something to relate it to this. Maybe this will work. Yeah, okay, so there was an unnecessary space was there. Anyway, so now we can see that the string is now being fixed to convert it into date. Okay, now what I want is, I want to use this as a reference date, and from this reference date how many days of data we have. Say if it is 5th January, from 1st January it is a 5 days. So I want to create a column with 1, 2, 3, 4 like that. Okay, so first what I will do, I will write a reference date which is simple a date and 1990 0101, and the format is, so I'm giving a string and then I'm telling, okay boss, this the format is this. Okay, so this is the, I'm defining a variable, and then I'm going to say that create a column df colon exclamation mark colon t, and in this you create a column where you just subtract time dot minus this reference date, put it in a, okay, yeah, so I'll just put it in this, and then if you just essentially print the first few columns, maybe 5 columns, so you can see that it has created a new column with the 0 day, 1 day, 2 day, 3 day, like this. But this is a day column. I want to convert it into integer, because at the end of the day I want to supply this t as a as a part of my model, because I want to check if over time this function, this average temperature is increasing or not. So I want to model average as a function of t. Okay, so that is what I want to do. So df colon t, sorry, no, I should have this exclamation mark colon t. So I have to convert this array to integer 64 int 64 comma d dot value for t in df exclamation mark comma colon t. Okay, and I want to just run this guy. So now you see the initial it was a day and now it is being converted into integer 64. So eventually I want to model t average as a function of t. So I cannot, and in the model I cannot give it as a day, it cannot handle day in the model, so I have to give it as a either integer or float. So that's why I need this column as an integer. I can define it as a float also. Actually technically I can define it as a float, no problem. Next, to handle seasonality I need so it's a daily data. I want to handle seasonality. Let me just put a note here. So note, we want to handle seasonality. So by adding sine omega t and cos omega t in the model, right? So we want to add sine omega t, cos omega t in our model. So you can ask me what kind of model we want to fit. Possible model could be like a simple model could be possible model could be easily say t average equal to beta naught plus, so t average is already there, t say and t we want to put, so beta 1 t plus beta 2 so we just want to take sine omega t to model the seasonality, then beta 3 cos omega t, right, plus epsilon. Okay, so this is the model that we want to fit. Suppose this is the basic model that we want to fit. Now we have t column, but we have to have a omega column as well, because sine cos can, the formula term can handle it, but we need to provide a omega. So let us define omega. What will be our omega? So this is an advantage of Julia, where you can, because it allows you to be use Unicode. So you can use Unicode for defining variable. Now, so I'm saying that 2 pi by f is my frequency of the day. So this is a year. On a year, I have 365.25. So technically we typically take year to be 365 days, but we know in order to handle the leap year, I am giving it as a 365.25 so that you will not have to, we don't have to worry about the leap year thing. So it will be automatically taken care of. So let us write this. So this is the value of omega. If you want to check, in fact, what is pi? Pi is 3.141. So this is all default setup. We just defined it. Now we want to add a column of omega, df, comma, colon. So W stands for omega. Fill with omega and how many? The size, whatever the size of the data frame, the first. So let me just what is size of the data frame? Size of the data frame is 11,894. So I'm just saying that create a vector of 11,894, fill it with the value of omega and add it as a column named as omega. So I want to print the first column, first 5 rows. Okay. So now you can see that we have a column with all values to be omega, the constant values and t values. All right. So I think now we are almost done. But remember that in the t average still we have this question mark, means there are some missing values are there. So let us drop those missing values because currently we are going to use a package called CRRao, which fits the simple linear regression, but unfortunately it cannot handle the missing value at this moment. So we are going to drop the missing df and print the size. So you see, before drop we have 11,894 rows. After dropping 11,867, so about 30 odd values were missing, but now it's better. We don't have to worry about the if we drop those missing, we don't have to worry. So if we just print the first 5 rows, since now there is no missing, so the question mark is gone. There is no missing now. So we have about 11,867 data points. And so now what we have to do, we have to split the data into train and test. All right. So I'll just make a comment. Split the data into train and test. Now the problem with this particular data is it's a time series data. We cannot randomly shuffle the rows and choose the data. So what to do? In this case, what we will do is from 1990 to 2015, we will use the older data we will use as a training data, and the newer data we will use as a test data. So first we will say date from we have to define from which date. So date is 1990 0101, date 2 2015 010. Sorry, we should take 1231. Okay, I don't want to print here, and my train data will be, so I'm going to use the TS frames subset function. It will take a time series data frame and subset the data by dates, and that's it pretty much. So okay, I think, I don't know, I have to first define the data frame as a TS and then TS frame. So okay, I will just do that before, in fact. So I'm just going to define it as a TS frame. I have not done that, so it will be defined as TS frame, and then I have to say that okay, this is from date, this is to date. Okay, so you can see this is a TS frame with the index date as the index, and rest of them are exactly same as it is, and from starting from 1st January 1990 to 31st December 2015. So 9448 rows are being included as training data. Now we are going to define the test data. So test data, I'm going to just copy and paste it here, but here instead of date from will be from 2016 0101 to 2022. Okay, and yes, and this will be test data. Okay, now if you run this, you can see that it is starting from 1st January 2016, it is ending at 25th July 2020, though I gave a 13. So it is just in that range, it will just whatever data, it will pick it up and give you as a TS frame. So now it is as a TS frame. Now we will just convert it into data frame, and that's it. Then we are ready. Convert it into train df equal to select train dot core data colon index colon tavg colon t colon w, and then we should do the test data as well, test df. Okay, I think we are done. So I think we are done. We'll do some visualization. That will be this is not a regular visualization, it requires a lot of more thing, but I'm just saying some visualization I'm doing just to see the how it looks like, but not a detailed visualization. I'm not going to do so using plots, I'm just going to do a plot, simple plot of train colon comma tavg size equal to 600. This is the width, this is the height. I don't want any label, so if you just run it, okay, so over time it has, you can see that there is a clear sinusoidal behavior. So let us try to model it. Okay, now we want to start do the predictive modeling with CRRao package. Now we can ask predictive model with CRRao package. So CRRao is a package that we are developing in CMI. The CMI students and faculty are developing. So what we are going to do, and so I'll give you the, so here is the, it's a complete open source development. We are doing it in GitHub. There is a lot of detail that we are doing, we have given. So CRRao is a package that essentially all of us based in CMI, well, Ayush and other, Ayush is in the partly Bombay, partly Delhi, so but we all are associated with CMI. And these are the current capabilities. It can fit linear regression, logistic regression, Poisson regression, negative binomial regression. Whatever model we are going to do in this course, all these problems, all these models are now part of this package. Now, along with, you can implement some of the Bayesian models also, which is beyond this course, but at least you will know that if you want to fit a linear regression with Gauss prior or Laplace prior or a horseshoe prior, you can very easily do that. And then automatically CRRao will figure out whether you want to do a frequentist model or Bayesian model. Automatically it will do that. In future we are trying to implement the mixed effect models, Gaussian process model, hierarchical Bayesian models. So lot of development activities happening. So you can please help us building this package. You can just, easiest thing will be like, if you go to the issues, there are some good first issues I have mentioned. You can try to implement those issues. Then or you can raise issue, if you can use this, and you can raise issues to report bug. So that will be this, how that is how you can help us with this package. If you like this package, then please hit the star button. It is like that will help us, encourage us to do more about this package. So to develop more about this package, if you don't like then some feature of the package, please write in the issues that okay, I don't like this package issues, or this feature, can you make this feature available, or something like that. And definitely we will try to do that. If you can help developing us, that will be even awesome. So I'm going to call using CRRao and some more things, stats models. So I'm going to, from stats model, I'm going to use formula and statistics. Okay, so let me call this. Okay, now so the first model, perhaps we can try this particular model we have discussed here, maybe. Okay, so why not? So the first model is model 1, fit @formula TAVG t plus sine w times t plus cos t times w times t. This is the formula. Then train, we have to provide the data set name, train data frame, and then we have to say which model class. In this case it is linear regression. So if you want to fit a logistic regression, then you have to say logistic regression. So like this only. Okay, so let me run. And here is the fitting of the model. Okay, so some summary statistics we can pull. Summary statistics, maybe R2 of mod 1 is the R square, and then adjusted R2, I think ADJ R2 mod 1 will give me adjusted R square. So I can then AIC will give me the AIC of the model, then BIC will give me the BIC of the model. Then if I call sigma, that will give me the standard deviation or residual standard error of the model. But these are all in sample summary statistics. Okay, now if we try, we'll do outsample statistics, but we want to bring another model, maybe a little bit more complex model, few more Fourier terms, develop a model with few more Fourier terms. Develop a model with few more Fourier terms. Okay, and then this is the second model. So, and what I'm going to do, I'm just going to copy this and just add this here and say sine 2 omega t cos 2 omega t. Maybe one more Fourier, 3 omega t cos 3 omega t. Okay. Three omega t cos 3 omega t, and rest everything is same. So let us run. It gives some warning, but I think all of them are significant. The time do have an effect, and all these Fourier do have an effect. And what we can do, we can just compare the maybe adjusted R square of model 1 and adjusted R square of model 2 as a vector. Let us see. So first model has a 72% accuracy. When we add second and third, these two Fourier terms, it jump up to 77%. But these are, both of them are in sample accuracy, so we will calculate the out of the sample accuracy. So let me just calculate out sample accuracy. TAVG predict 1 equals to, so I'll just say predict mod 1, and I have to give test data frame. Okay, test data frame. Okay, and maybe I'll just calculate the second one with second model. So this gives me the predicted value of average in the test data frame. Now what I'm going to do, I'm going to calculate the root mean square error. Root mean square error. So RMSE1 equal to square root mean of first from test, sorry about that, test data frame, you calculate T average, sorry, extract T average, okay, minus, you just take the first prediction from the first model and square. So this is a broadcasting operator, and then it should work, and then let me just run it. So yeah, 1.49, and then this is the second one, RMSE of the second one. So this is 1.36. So now what we can do, we can just compare the RMSE1 and RMSE2, which is in sample, out of the sample RMSE1 and out of the sample RMSE2. The second one is clearly much better, and also we can calculate the sigma, which is in sample RMSE mod 1 and sigma mod 2. So clearly in both cases RMSE, of course out of the sample RMSE is slightly more than the in sample RMSE, but this is definitely better. In second model is definitely better in this case. Okay, our model accuracy is doing reasonably okay, about 77-8% accuracy we are getting. Even if in the out sample probably we are getting little, maybe around 70% accuracy. Now still we have to do some model checking, model assumption checking. So check the assumptions, and at least if it is doing normality or going well or not. Check model assumptions. At least first thing we have to check is model assumption. For the second model, we don't need to check model because we are not going to use the first model in any way. Second model is significantly better than the first model, so we will just do the model assumption of the first model. So let's check first normality. Check normality. So what we will do, we will just run a Kolmogorov-Smirnov test for normality using hypothesis testing is a package, and distributions. Okay, so case test is exact one sample KS test, and we have to give residuals. Okay, so what we will do, we have to first, so resid 2, from the resid 2 will help me imagine, okay, this is from the model 2, resid residuals from mod 2, and this needs to go to like Kolmogorov-Smirnov test with normal distribution. The test will be against normal distribution. So let me just run this. Okay, it's saying that I don't have the hypothesis testing. So let me just pause the video. If I just run this piece of code, it's saying that it will import the hypothesis testing. So let me just pause the video and I'll come back. Once I'll install and I will come back. Okay, I realized that there was a spelling mistake. It should not be hypothesis testing. This should be hypothesis tests. So that's what the issue, I think. So let me just run it. Yeah, and it's ran, and for two-sided test, the p-value is really, really small. In fact, if you just want to see what is the p-value, if you just provide the test itself, it will extract the p-value and print it for you. So it's like really small p-value, so you cannot really test the model. So what we will do, we will just also check how the actually residual behaves. So is it really bad? Let me just do residual resi2 with no level, maybe. Okay, histogram. I have to just write histogram. So okay, this is the histogram of the residual. It's not bad. It's almost like a bell-shaped. Only thing, it has a bit of a long negative tail. So that means that it has essentially it means the way, if you see, it looks like it is underestimated. It is doing some underestimation probably. So like an underestimation happens when probably if a model is saying that okay, it will be 30 degrees Celsius and turns out to be it is 32 or 33 degrees Celsius. So naturally there will be a negative of the negative residuals, and that residuals we are seeing here, there are quite a almost 6 degree difference in the predictions, and that has also happened. So let me just stop here. So that means normality is an issue. Model's predictive accuracy is reasonably okay, almost 70%, 78%. So we cannot, if we want to go and say that okay, this is beyond reasonable doubt, that the main problem that we will face is here, and I'll tell you what the problem is saying. So based on these analysis, when we are running this model, based on this analysis, the coefficient of t over time is positive, it is increasing, and p-value is really small. Confidence interval does not include 0. Now the problem now we are facing is, so based on this, Chennai's temperature is increasing. Now somebody can come and say that, well, your underlying assumption is that your residual follow normal distribution. Your normality assumption does not hold good. Okay, clearly normality assumption doesn't hold good. Kolmogorov-Smirnov test reject that assumption. Therefore these inference that temperature on an average temperature of Chennai is going up over the last 20 years, almost 30 years, is not correct. It's not correct because your underlying assumption is wrong. And what is the probability that it will be correct? The way to solve this issue is very simple. We know that we have to run bootstrap regression. Residual bootstrap regression does not, or even paired bootstrap regression does not rely on the assumption of normality. In fact, it assumes that any residual follow any probability distribution with some mean and variance, and looks like this is fine. The mean 0 is assumption is fine, and some variance is also fine. So we can implement this model using bootstrap regression. So I am leaving this to you, as we have already studied bootstrap regression. I am leaving it to you. Try to write the bootstrap regression and implement this. I will share this Jupyter notebook in the NPTEL's forum, in the NPTEL's platform, in Swarm platform. Please go there, download this notebook, and also the data will be available there. I already shared the data with you. Please go ahead, download this notebook and implement the bootstrap regression using CRRao package. Okay, so CRRao package has not implemented the bootstrap regression yet, but I think you can do it very simply, quickly by yourself. We have done it in R. You have seen, basically you have to translate that code into bootstrap regression. So with that, I will stop here. Thank you so much. Take care. Bye.